Welcome to another interesting session with Emmy. We'll take up examination style question and understand how do we solve such problems. You may join my classes, gain confidence, connect learnings, and get ready for future. Share the gift of education. Let us now enjoy the lesson with Emmy. Hi, Emmy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Very good, very good. So today, what do you want to do?
So still kind of continuing with the revision. I had a couple questions on the pure side because that will be the first two papers that I'll do next week onwards, and then it'll be stats and mechanics. So I'm leaving that to last now because that's and plus it's only not as much a percentage as the pure side, so I have to focus now on the pure. But yeah, I was just wondering in terms of revision and prepping. I've kind of done most of the questions. Hopefully I kind of understand most of the topics as well. It's just how much more we just keep doing practice questions, or is there other ways to make it a bit more effective?
Okay, so I have a strategy for it, and that is, your pure. We can just go through the contents of your pure test, and let's say there are 10 chapters, and
Yeah.
we can just touch upon what are the important things which you should cover definitely for the test, because there are a few topics which are very commonly asked in every test paper. So that becomes a very important set of topics which you should not miss at all. And
Yeah.
then there are the other topics which are not so critical. So that could be a base for our preparation. Now, how many days to go? Normally, as I've seen your test papers, every question will have a couple of parts, and in those parts, they will touch upon each and every chapter. For example,
Right.
binomial theorem can be one part of it, and then there could be integration on that particular question.
Yeah.
Even derivatives, even they could combine it with sequences and series. So, so you need to have a very good understanding of all that. Anyway, so I will actually prepare something for you to share after the class. For now, you can share with me which all questions you find slightly difficult. We'll try to find the best way of solving them. Is that okay?
Yes. Thank you, sir.
You can share the screen. Yes.
So, okay. Question 13. Yeah, this was a differentiation question. And yeah, kind of using trig as well. So the intertwining differentiation and trigonometry.
Got it. So we'll go get into all the concepts related with the question so that you do not have to do many questions on that. You get the idea. That is my approach today. Right. So share the question. We'll look into it.
Question 13.
Okay. Let's try to understand the question first. When you look at it, x equals to 2 cos t, y equals to square root 3 cos 2t. It means it's a parametric equation also. You get it? And then I see dy dx means derivative. You understand? Differentiation also. So they have combined trigonometry with, of course, parametric equations and derivatives. Now, let us look into the question. Can you please read the question?
Yeah, so the curve C has parametric equations x equals to 2 cos t and y equals to root 3 cos 2t, where t is in between 0 and pi, both included. Part A. Find an expression for dy over dx in terms of t.
Correct. In terms of t. Correct. And then the point P lies on the curve t equals to on C, where t is 2 pi by 3. The line L is normal to C at P. Show that the equation for the line L is given to you in this particular form. Correct. Now, find the expression for dy by dx in terms of t. So you have to find what y is, basically in terms of x. Then you will differentiate it. You get the idea, right?
Yeah. And therefore, so like dx dt like that, and then dy over dt.
So you have cos t here and your square root 3 cos 2t. So how will you approach? Tell me.
So dx over dt. So you would have to use the product rule, and so when you'll do 2 times sine, so minus sine t, because cos t when you differentiate.
No.
Oh, you're nodding your head that it's wrong.
So you are jumping into the solution, and that is a trap. So first thing is find an expression for dy by dx in terms of t, right? So yes, you could do dx dt, dy dt, and then you can find dy dx, correct?
I was going to flip the dx over dt and then times
You
the
could do that.
results.
And then it says the curve C has a parametric equation, right? Whenever you are given a parametric equation, it is also a good idea to write the equation in general form. I mean, you
Oh, the
understand?
Cartesian form. Yeah.
Yes, because see, you remember double angle formula? So what is cos of 2t equals to? Since you are given cos t, which is half x, let's write down what is cos 2t. Cos 2t in terms of cosine is equals to 2 cos square t
-1.
minus 1. And now, that is cos 2t, right?
Yeah.
So instead of cos t, we can replace it with half x. You understand, from this equation,
Yeah.
I could write that cos t is equal to half of x, is x by 2, correct?
Yeah.
So now look at it. You have equation y equals 2. So we'll say y is equal to square root 3 cos of 2t, right? So instead
Yeah.
of cos of 2t, I'm writing 2 cos square t minus 1, right? We are not jumping into the solution. We're trying to understand all the stuff around. Is it okay?
Okay. Yeah.
So this is square root of 3 and 2 times what is cos t? Cos t is x by 2. So the square will be this
X
square,
squared
right? X
over
squared
4.
by 4, right? So
Yeah.
I'll replace this by x squared over 4 minus 1. Does it make sense to you?
Yeah.
So now we have y equals to square root of 3. Within brackets, we have x squared by 2 minus 1. Correct?
Yeah.
You could actually no harm in also writing this as y equals to square root of 3 by 2 x squared minus square root of 3. Correct? Correct? So, oh, okay. They wanted to write in terms of t. That is why you did not do it. I see. I get
I
it.
did that though in the beginning because it was kind of like, normal to like bring the Cartesian equation.
I see.
I think we need it later actually.
We
so
need it
it's
later
fun.
because I was looking at
Yeah.
the final equation and I thought, let me get there, right?
Because
Anyway.
that equation is in y and x. So
Yeah, that equation is in y and x. So let me just put this now. Yeah, for part A, you do not need it. You get the, you are right. So you have square root 3x as dy dx. Perfect.
Yeah.
Now let's get back to part A. Wow, I actually did not read the question perfectly. So find the expression for dy dx. So you have to differentiate in terms of t, right?
Yeah.
So dx dt is what?
So would it be 2 times minus sine t?
Minus sine t, right?
And that's it.
And for dy dt?
So root 3
minus, because cos 2t also
2
times 2, right? Square root 3, right?
Oh my god, I'm such an idiot. When I just looked at it again, I just realized where I went wrong in my question. Yeah. Minus 2. Yeah, sine 2.
Right. And so therefore dy dx is,
you would have to flip the dx dt, so 1 over that, because we want it dt times dx.
Yeah. So you can write like that, dy dt times, you could say dt dx, right? Or you can say, yeah.
You can just divide.
You divide, but you can write dt dx, right? Reverse it, flip it, right?
Yeah.
No need to write this step, but you can write down the answer, right?
Yeah.
So I'll write down dy dx as equal to, so dy dx is minus 2 square root 3 minus 2 square root 3 sine 2t. And I'm dividing by dx dt, which is minus 2 sine t, right?
Yeah.
So now you can see sine 2t is 2 sine t cos t. This cancels, minus cancels. And we have square root 3 times 2 Sin t cos t, correct?
Yeah.
Divided by sin t. And sin t cancel. So we have 2 square root 3 cos t. Is that okay?
Mm. Yeah, so my question was, like, how do you know, like, what to leave it in? Because when I did it, I just left it as root 3 sine 2t and over 90. And the answer had that as well, but then I was going to simplify it. But how do you know if it doesn't say?
You have, I think by default, you should simplify it to the lowest terms or, of
Okay.
course, and the simplest form, right? So when
Yeah.
I'm seeing sine 2t, it's a double angle formula. And I have sine t in the denominator. So therefore, I'll definitely go for a simplification. 2 sine t cos t,
Okay.
cancelling out the common factors, and write down 2 square root 3 cos t as my answer for part A. So we have dy dx as equal to 2 square root 3 cos t. Is it okay?
Yeah.
And from the first equation also, we had square root 3x. Do you see that? And x is 2 cos t. So we get the same result. You can compare.
Oh, okay. Yeah, yeah.
If you compare this with what we had earlier got in terms of x, and you want in terms of t, x is 2 cos t, correct? I could substitute here 2 cos t, get the same result, right? So we do get the answer, which is dy dx equals to, which is same as 2 square root 3 cos t. And you know 2 cos t is x. So we could write this as square root 3 x. Is that clear to you? They get connected, right? Okay. So we have done the first part. Let me, you have copied this, right? Make a note.
Yeah.
Make a note. Can I erase the screen?
Oh, wait, let me just quickly write
Yeah, right.
one equation. Perfect. Okay. Yeah.
So in this, we have seen double angle formula, a lot of trigonometry involved, huge amount, parametric equations and derivatives, 3 chapters. And these 3 are very important chapters. By doing only this example, you have understood all the concepts. Now,
Right.
the point P lies on the curve C, where T is 2 pi by 3. So T value is given to you.
Mm-hmm.
The line L is normal to C at P. So we have to, the derivative will give you slope, right? Normal will be negative reciprocal. Show that the equation of L is normal, right? Is this. So now we know the derivative. So let's find dy dx. So let's find dy dx at t equals to 2 pi by 3. So what was the equation for you?
With the root 3x.
2 square.
Are we doing, wait, are we doing dy dx of the line?
Line. So because we found in the first case the expression for dy dx, right? So we'll use the same expression. Is it okay?
Yeah.
So plug in 2 pi by 3 in this.
2 pi over 3 minus a half is 2 pi over 3, like cos 2 pi over 3 times 2 root 3.
Yes. So as you know,
minus root 3.
Yeah. So basically, you have to understand this part also, because cos 2 pi by 3 means you are here, right? So we are reviewing all other concepts as we move along. It's an acute angle of pi by 3. And as you know, in a special triangle, for pi by 3, the cosine value is half, right?
Yeah.
And you are in quadrant 2, so it is negative.
Negative.
Therefore, this is equal to negative 2 square root 3, and this value is half, and we get negative square root 3 as the derivative. Is it okay?
Perfect. Yeah.
Now we know that the line L is the normal. Normal slope of normal will be negative reciprocal. That means negative of negative 3 reciprocal will give me 1 over square root 3 as the slope, correct?
Yeah.
Now it says show that the line for L is this. Now we know x, we need to find x and y coordinates, correct?
Yeah.
So find the value of x for t equals to 2 pi by 3. So when you substitute 2 pi by 3 for x, you get what? X is equals to 2 times cos of 2 pi by 3, right? So this is 2 times negative cos of 2 pi by 3 is half, correct? So which is
Yeah.
negative 1, correct? X coordinate. Y value is square root 3 cos of 2 times 2 pi by 3 means 4 pi by 3, correct?
Yeah.
4 pi by 3 will bring it in this quadrant. Still remains negative, correct? Of pi by 3, correct?
4 pi. Yeah.
Which is same as square root 3 cos of pi by 3 with a negative sign.
Minus a
It's
half.
still minus half, so minus square root 3 by 2, correct?
Yeah.
Therefore, your points are minus 1 and minus square root 3 over 2. Is this correct?
That's the point P. Yeah.
That's the point. Now you know the slope, and you can write down the equation as y minus y1 equals to m times x minus x1, correct?
Yeah. And plug it in.
So y minus y1 in this case is minus
Plus.
square, so it becomes plus here, equals to m, which is 1 over square root 3, times x minus x1, which is
plus 1. Yeah.
Now you can multiply by square root 3, so you get square root 3y plus 3 over 2, right? You can multiply by 2 also, right? Because we don't want any denominator. So you get 2 here, equals to 2 times x plus 1, correct?
Yeah.
Now you can open this bracket and you know the answer. So you
and then you get
square root 3y plus 3 plus equals to 2x plus 2, right? Bring them all together. So we have 2x minus 2 square root 3y minus 3 and minus 3 plus 2 equals to 0, which is the same as 2x minus 2 square root 3y minus 1 equals to 0. Is that clear?
As required. Yeah.
So we do get these 5 marks with a lot of work, but it really requires that amount of work. You get the idea?
Yeah. Yeah. But these are like, not trying to be like, but it is nice marks to bank, is what I'm saying. It's not like really, really hard. Everything is kind of given, and they're like one of them, like that one was a show that question for 5 marks. At least we know where we're heading. For that many marks, at least we know what the answer is. We just have to kind of get there. So try and like get those marks. That's what I'm saying. Yeah.
Perfect. So we have done this part. Next part is even good. The line L intersects the curve C again at the point Q. So you have this equation of the line, and you have to find the coordinates of Q. How will you do parts C? Tell me.
So you'll take the line that we just calculated, and we've got our Cartesian equation of C. And when I did it, I just basically subbed in.
We earlier calculated. What was the Cartesian equation? Can you please tell
y equals root 3 over 2 x squared minus root 3. So I just took that equation of y and subbed it in that line one, and it solved. It's really nice answers. So that was relatively straightforward, that question.
Got it. So substitute. So the Cartesian equation really helps in part C, which is 6 marks. Now look at it. Which is 6 marks?
5, 6.
Correct. So if you really look at the question, what should be your approach? I think the approach should have been find this Cartesian equation. You get the idea?
Yeah.
So from here, we get dy dx very easily, which is square root 3 of x, correct?
Yeah.
Since I want in terms of t, and I know x is 2 cos t, I will write 2 cos
just sub it in.
Yeah, 2 cos t. Do you get the idea?
Yeah.
So I got these 2 marks. They were worth 2 marks. You get the idea?
Yeah.
But the method which we adopted, it was a very long method. And therefore, this approach helps. And this equation helps you to find the answer for part B and C also.
Oh.
Because you need to ultimately find the coordinate point y for the given x value.
Yeah.
We did calculate x equals to 2 cos of 2 pi by 3. We did all those calculations. Why not start with those calculations?
Yeah. So what you're saying is that we wasted time doing it the long way in terms of finding because if you look at the marks, you can see that it's only 2, so you wouldn't have to do it like that. You have to find a better method, because if you find the Cartesian equation already, then when it comes to the 6 marker, you've already saved time.
Yes. So let me go through this. Rather, Amy, can you describe? See, look at the distribution of marks. You get the idea. So first
Mm.
thing first, read the whole question because all are connected. Do you understand?
Oh yeah, I
Once
have
you
this
read,
weird bad habit where I just read the first question because
no,
like that's why we're kind of taught we can't read the whole thing, just the one. So that's why I keep only going halfway, and that's why I keep getting in this trap. Because if I read the whole thing, you can understand that later on you would need the Cartesian equation and then do it. Yeah.
even while Amy, you were reading, I was actually scanning the question. And therefore, when you
Oh
stopped at this point, I continued and I said, well,
yeah.
let's read that. But I thought, okay, you have already done this, so let's go to it.
Yeah.
But
No, don't.
if you also scan the question, you can see very clearly that Cartesian equation is the main equation to work with.
Right.
We have two options. Parametric equation they started with, right? And
Mm-hmm.
normally in any equation, parametric equation will lead to the Cartesian equation.
Cartesian. Yeah. Almost
And
always.
that will lead to all the solutions easily because you are familiar with Cartesian equation. So the
Right.
familiarity helps.
Speed as well will come with it.
Correct. Speed will come with it. And part B and C easily can be done once you have your Cartesian equation on the side.
Yeah. Yeah.
In fact, we also saw having a Cartesian equation, getting the derivative from there, right? And
You could
substituting
do
the
part
value
A.
of cos t helped us to get the solution of part
Yeah.
A also.
But to be fair, for this lesson I wouldn't have seen the correlation between the two. Like yes, I got root 3 cos t, but I wouldn't have, or whatever it was, I wouldn't have seen it like with x. I would never have like done that. So now I know that if I get it in terms of x, just try and use the parametric and then sub it in, then you get your dy dx.
Yes.
I didn't realize.
And look here, they are given a point P, right?
Yeah.
They're saying point P lies on the curve C, T is this. Why not from here just substitute and find what Y is?
Yeah. Yeah.
So you have a coordinate point to work with, which can help you later, correct? You get the idea.
Right.
So if you read the question, now with practice, you will understand what method should be adopted, and the weight over here is clearly telling you that the method is go for Cartesian equation.
Yeah. Yeah. So you're saying, like, with certain questions, just do certain things already on the side, because that, whether you like it or not, you're going to use it. Like with
Yes.
graphs, we always write domain and range. Whether you like it or not, you're going to use it. So you might as well with this one also just write the Cartesian, because it's going to come up. You can see the length of the question, it has to come up. So just write it anyway. No harm. Okay.
Because with my experience on working with Edexcel or GCSE or IGCSE test papers, they try to throw you off the track. And that is the strategy rather than, the question is not very difficult at times. But when you're on the wrong track, everything goes against you.
And it becomes hard. Yeah.
So first, understand your approach to solve the complete question, not each part.
Okay. Yeah.
Then you will be probably doing it the best possible way, and that is what is required. We cannot afford to lose time in such a test. Is it very critical? Okay.
Right.
So I think this you have reviewed very clearly trigonometric equations, parametric equations, even derivatives, and therefore you do not have to go back to that chapter. Think like this.
Oh, okay. We've covered a question on all these topics.
Covered. So now let's take up the next question.
Nice. Okay. So this is how we should revise. Is that what you're saying?
So you just put a check mark there, right? If you still think there's something, okay, we'll look into that also.
Perfect. Okay.
Then another question. Involves trigonometric function right there. So can you tell me, read the question, then we'll begin.
Read the whole question. Learn my lesson. Yeah. Okay, so figure 5 shows a sketch of the curve with the equation y equals f of x, where f of x is 4 sine 2x over e to the power of root x minus 1. Yeah, where x is in between 0 and pi, both included. The curve has a maximum turning point at P and a minimum turning point at Q, as shown in figure 5. Part A, show that the x coordinates of point P and Q are the solutions of the equation tan qx equals root 2. Then part B, using your answer, part A, find the x coordinate of the minimum turning point on the curve with equation y equals f of 2x and y equals 3 minus 2 of f of x.
Correct.
Like translations and transformations.
Okay. So the important key point here is, again, the weightage is 4, 4, very good. At least you know the answer of part A.
Yeah.
Let us say by any chance you're not able to solve part A. You know tan 2x equals to 2 is the solution, and you can actually do part B without even solving part A. So remember that part. So even if you do not get part A, you can still get 4 marks of part B by using this as your given
Answer, right?
answer, right? So now let's try to get the answer, right? So that's very important to understand. So it says